All right, hello everyone. My name is Michael, and we're going to be looking at problem 10 from the team round of High School Test 12503, which was the release for December 2024. So let's go ahead and take a look. Let t greater than 0 be a real number that satisfies the equation e to the 2t plus e to the negative t equals 3, where e represents Euler's number. There exists a real number r that satisfies the equation e to the 6t plus e to the negative 3t plus r equals 27. Then r is the root of the cubic polynomial x cubed plus kx squared plus lx plus m, which is integer coefficients. Compute k plus l plus m. Now, we can see pretty quickly from the two given equations that kind of looks like they're cubed, right? But we know from our math days that just because x plus 1 over x equals 5, that does not mean that x squared plus 1 over x squared equals 25. Similarly here, e to the 2t plus e to the negative t is 3, but e to the 6t plus e to the negative 3t is certainly not 27. Now, to make this easier, right, I am going to use a substitution. X is already used, so let's say that y is equal to e to the t. Then that first equation becomes y squared plus 1 over y equals 3. Now, we are going to cube this equation. If I cube this equation, y squared plus 1 over y cubed equals 3 cubed, I'm going to get y to the 6th plus 3y cubed plus, that just cancels out, right? Yeah, plus 3 plus 1 over y cubed equals 27. Now, our final equation, right, has the form, right, e to the 6t plus e to the negative 3t plus r equals 27, which using the substitution of y equals e to the t is y to the 6th plus 1 over y cubed plus r equals 27. So we have this pesky 3y cubed plus 3 in the middle right here. Now, what are we going to do with that? Well, we can, right, also multiply this equation by y squared plus 1 over y equals 3. When we do that, we get that y cubed plus 1 equals, actually not the right xy, right, times y, is going to be equal to 3y. So therefore, right, we can substitute 3y in for y cubed plus 1. And that's going to give us y to the 6th plus 3 times y cubed plus 1 plus 1 over y cubed equals 27. So therefore we have y to the 6th plus 3 times 3y is 9y plus 1 over y cubed equals 27. And therefore, right, that gives us that r is equal to 9y, right? If we compare these two equations right here and right here, the only difference is that the left-hand side, one has an r and one has a 9y. So therefore, r equals 9y, and that gives us that y equals r over 9. Now, what are we going to do with, y equals r over 9? Well, we can now simplify it back into this equation up here. And what does that give us? That gives us that r over 9 cubed, right, plus 1 equals 3 times r over 9. Because we're trying to find a polynomial of which r must be a root, right? Now, doing this gives us the equation 1 over 729r cubed plus 1 is equal to r over 3. Now, since everything, we have to have a leading coefficient of 1, we're going to multiply this by 729, move everything to the left-hand side, and that gives us that r cubed minus, we'll say plus 0 r squared minus 243r plus 1 is equal to 0. Not plus 1, plus 729, excuse me. Now, r satisfies this, right? So therefore, r is a root of the cubic polynomial that we're looking for can be attained by just replacing those r's with x's. So we have x cubed plus 0x squared minus 243x plus 729 equals 0. So using this, we can find our coefficients, which are going to be k equals 0, l equals negative 243, and m equals 729. So therefore, k plus l plus m is going to be 2 times 243 is 486, and that is our answer to question number 10.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.